Welcome to Math with Millie
and Ziggy.
Yes, and Ziggy. Today we're talking about perfect squares.
What? Are they going to heaven on wings?
No. Remember how a square root of a perfect square number is a whole integer?
Oh, like the square root of 25 is 5 because 5 times 5 equals 25.
Right. And 36 would be another perfect square because the square root of 36 is a whole integer. And what would that be?
The square root of 36 is 6. It would be 6 times itself.
Right. So perfect squares mean a number that when you square root it, you get a whole integer.
Okay, so what about 29?
29?
Yeah, would 29 be a perfect square?
Well, you tell me, Ziggy. A perfect square means the square root of that number is a whole integer.
29. What times what equals 29? 4 times 4 equals 16. 5 times 5 is 25. There's no whole integer times itself that equals 29.
So then
29's not a perfect square.
Correct. So let's draw a number line here. And since 29 is between the perfect squares of 25 and 36, that means the square root of 29 is between the square root of 25 and 36, like this.
Okay.
So the square root of 29 is somewhere between 5 and 6.
Okay, so since the square root of 29 doesn't equal a whole integer times itself, it's not a perfect square.
Correct. Right.
Okay.
So we'd say that the square root of 29 is somewhere between these two consecutive whole numbers, 5 and 6.
Okay. Yep.
All right. So here's the question, Ziggy. Between which two consecutive whole numbers is the square root of 200?
Not gibberish again. Speak English, please.
Well, we gotta guess, Ziggy. Sometimes in math, we just need to take a wild guess and see if it works. And then we go from there.
I like wild geeses.
No. Not wild geese. A wild guess.
Oh, guess.
So in this case, let's make a wild guess. We know that 100 is a perfect square, right? Because it's 10 times 10, right? So the square root of 200 is going to be more than 10. So let's do a wild guess. Let's try 20.
Okay, let's wild guess. So let's check our guess. Okay, 20 times 20, 400. That's too big. Oh, way too big.
Correct. Our guess was too big, too large. So why don't we try 15 next?
Okay, 15 times 15, that equals 225. Oh, still too big.
Okay, so let's try now. Let's try 14, Ziggy. 14 times 14 is what?
14. 14 times 14, 196. Oh, man, now it's too small.
Okay. So what we found out, Ziggy, is that 14 is less than the square root of 200,
yeah, it's less.
Right?
It's too small.
And that 15 is more than the square root of 200,
it's too big.
Right?
Yeah.
So that means the square root of 200 is somewhere between the consecutive whole numbers of 14 and 15, right?
Oh, I get it. So when we want to try to find out the square root of a number, and we know it's not a perfect square, and that it lies between two consecutive whole numbers, we just got to chase wild geeses.
Well, we do a wild guess.
Okay.
Yes. Until we find which two numbers multiplied by itself is just below and just above that square rooted number.
Oh, that's so cool.
But we can take it a step further.
No more steps. There might be a cliff. We'll fall off the cliff.
Well, Ziggy, this is math, and there are multiple steps sometimes.
Okay, fine. I guess wild geeses fly off cliffs anyway. What's the next step?
Okay, well, we figured out the square root of 29 was somewhere between the 5 and 6, right, on the number line?
Yeah.
Well, we can refine that estimate by finding a decimal or a fraction that's closer to the actual square root of 29. So let's look at the number line again.
All I see is the square root of 29 is somewhere between 5 and 6.
Okay, so time for some more wild guesses. Let's see if 5.4 times itself is closer to 29. Okay, let's try it, Ziggy.
Okay, fine. 5.4 times 5.4, 29.16.
Okay.
It's too big.
So let's go down a smidge. Let's try 5.3.
Fine. 5.3 times 5.3 is 28.09. It's too small.
So, since the square root of 29 is somewhere between 5.3 and 5.4, we will never even find a decimal or a fraction that equals the square root of 29. So instead, let's just use our calculator.
I like calculators.
Okay, so let's find the number closest to the square root of 29. We need to enter these keystrokes, okay?
Okay.
Square root 29 equals, or 29 square root equals. It depends on your calculator.
Okay, great. So I will compute. Computing square root 29 equals. The calculations are in.
Okay, so what's the answer, Ziggy?
The calculator states the answer is 5.3851648. Yes, we did it.
Okay, so that's the number that's closest to the actual square root of 29, but it still isn't exactly the square root of 29, right?
Right.
The actual square root of 29 is a number that cannot be expressed as a decimal or a fraction. So therefore, it's not a rational number.
Oh, so sorry, square root of 29. You're as mad as a March hare. You're a silly, senseless, harebrained, half-baked, crazy number. Hey, wait a minute. Harebrained? That's offensive.
No, Ziggy, not like that. An irrational number means that the number cannot be expressed as a ratio of two integers.
Huh?
Well, in other words, irrational numbers cannot be written accurately as a fraction or even as a decimal number. For example, the square root of 29, right? We found it cannot be expressed as an actual fraction or a decimal. So we just leave it as the square root of 29. That's the answer. It just stays irrational.
Huh?
Okay, so here's a short 1-minute video that might help explain what an irrational number is, okay?
Okay.
Let's watch it.
To understand what an irrational number is, it helps to know what a rational number is. A rational number is any number that can be written as a ratio of two integers. Does that sound familiar? Yup. A ratio of two integers is a fraction, like 1/2 or 2/3. So any number that can be written as a fraction is a rational number. But can't all numbers be written as a fraction? Surprisingly, the answer is no. Sure, any whole number can be written as a fraction by giving it 1 as the denominator, and any decimal number that you can write can be written as a fraction by having the proper power of 10 as the denominator. So all of these are rational numbers, and there are a lot more. Infinitely more. Any number that can be accurately written as a fraction or a decimal number is a rational number. But there are numbers that can't be written accurately as a fraction or even a decimal number. Those numbers are called irrational numbers because they are not rational numbers. One of the most famous irrational numbers is pi. And you might be confused because you may have heard that you can represent pi with a fraction like 22/7 or 355/113. But those are just approximations for pi, which means they get close to the value of pi, but they are not exactly equal. You can't get the exact value of pi with a fraction no matter what numbers you use. And you've probably seen pi written as a decimal number, like 3.14 or 3.14159. But those aren't completely accurate values of pi either. Again, they're approximations. If you tried to write a completely accurate decimal number for pi, or any other irrational number, the decimal digits would never end and won't repeat.
Okay, I get it now. An irrational number means we can't accurately express the number in a decimal or fraction form.
Correct. Nevertheless, the square root of 29, which is an irrational number, does have an exact value. But it's just written as the square root of 29. You can't change it into a decimal or fraction, because if you do, it won't be as accurate. So we just leave it as the square root of 29, okay?
Okay, so now that we know what an irrational number is, we're done.
Not yet. I want to show you how the square root of 29 can be the length of a hypotenuse.
What? How could that be?
Well, let's say we have a right triangle that's 2 centimeters on one leg and 5 centimeters on the other leg. And the hypotenuse is the square root of 29 centimeters. Do you remember the Pythagorean theorem?
Yeah, let's see. It's one leg squared plus the other leg squared equals the hypotenuse squared. So a squared plus b squared equals c squared. Woo!
Right. So let's do this. 2 squared is what?
4.
And 5 squared is what?
25.
Okay. And so we're going to add those 2 squared areas of the boxes over the legs.
A and B.
So that's
Yeah.
25 plus 4. And that's going to equal what?
29 squared.
Great. So then we know now the area of this box on the hypotenuse is 29. So to find the length of one of the sides of this box, to find the length of the hypotenuse, how do we do that?
I remember. We do the square root.
Right, Ziggy? So the square root of 29, right?
Yep,
The square
and
root.
we already know we can't do that, so it stays as that number. The square root of 29. That's the answer.
Right.
That's the length of the hypotenuse.
Yes. Yes, right, Ziggy. Great job.
We're done.
We're
done.
Well, one more thing.
Great.
I want you to draw a number line and show me the location of these 3 different numbers. Are you ready?
Sure, why not?
Okay. Now, some of these numbers are rational and some of them are irrational. And do you remember what that means?
Yes. Irrational means you cannot write them in a decimal or fraction form. They just stay like a square root number.
Right. Okay. So here are the numbers. And the first one is pi.
We're eating pie?
No, 3.14 pi.
Oh.
Do you know where we would put that on the number line? Okay, let's draw a number line. -1 up to 4.
Okay.
So where do we put the 3.14?
Right,
Yeah,
right there.
here.
Yep.
Now make sure the 3.14 is closer to the 3 than the
Okay.
4.
What's next?
So now let's do the square root of 2. Ziggy. Are you listening? Ziggy.
Yeah, I just don't know what you mean.
Okay, we need to put the square root of 2 on this number line.
Okay, but how?
Okay, well, remember, we just do wild guesses.
Wild geeses! Yeah!
Wild guesses.
Oh,
So let's see if we can find the square root of 2. What times itself can equal 2?
is it 1 times 1? No, that's 1. That's too small. Is it 2 times 2? No, that's 4. That's too big. Ugh.
Okay, so where do we put the square root of 2 on the number line?
I guess it's between 1 and 2.
Good. Because 1 was too small and 2 was too big. So it's somewhere in there. It's between 1 and 2.
Yes.
So now what about this other one? -1/2. Where would that go on the number line?
That's easy peasy. -1/2 would be between 0 and -1. Silly.
Right, because that's
Silly.
a rational number.
Yes.
That's pretty easy to do, right? Okay, last one. Where would 2.3 with a line over the 3 go? I mean, that means 2.3333333 forever.
Well, I heard once that 0.3 is sort of like 1/3, but not exactly.
Right, you heard correctly. So 2.3 would be like 2 1/3, right?
Right.
So where would
Yep.
that go on this number line?
Well, 2 1/3 would go after the 2, closer to the 2 than the 3 because it's 1/3 after the 2.
Great. Good job, Ziggy.
Woo!
So we hope you enjoyed this episode, and we'll see you next time. We really enjoyed doing math with you.
Yes, we did.
It's time for a nap.